Recording process, okay. So today's session, we will be starting with the understanding of the final type of vector operation that we have to study, which is called the cross products. Okay. Also called vector product. Or vectors. Okay. Last couple of times, we've been looking at dot product or scalar product of vectors. Start by understanding this new type of operation, and then we'll do some revision questions also later. So, cross product of two vectors. The symbol used for it is this. It's the cross symbol. So, this is read as vector E and B's. Cross product. Vector product. That is the symbol used for this. Now, the definition is that E cross B equals to magnitude of E into magnitude of B into sine theta multiplied by a unit vector n cap. Okay, so this is the definition, where E is nothing but magnitude of vector A, B is nothing but magnitude of vector B, theta is the angle between the two vectors, but most importantly, n cap is a unit vector perpendicular to the plane of vector A and B. I'll explain more about this now. So just note down the definition and the symbol. Yeah, Piyush, I understand you've just joined, but I'm showing you the slide from the beginning. Okay, so yeah, practical example, Raj, I'll be giving you. In fact, that's why we are discussing the product, so that now we can start gradually understanding the applications of these things. For example, last time I told you that scalar product or dot product is used to calculate work done, and the interpretation of that also I told you, it is one vector multiplied by the component of the other vector or the projection of the second vector along the first vector. So like that, by the time we complete cross product, I will explain to you how the applications of this also work in physics. Okay. There are a lot of applications actually. So first, let's go step by step. First, let's understand the definition of cross product. So the definition of cross product is given by this, that it is equal to AB sine theta multiplied by a unit vector, because the quantity AB into sine theta is a magnitude. It is magnitude of A multiplied by magnitude of B multiplied by sine theta, where all three quantities are scalars. Mod A, mod B, and sine theta are scalars. But the moment we multiply it with this n cap, it becomes a vector quantity. Now we'll see how we define n cap exactly. But one of the ways to understand n cap is that it is a unit vector. That means it's a vector of magnitude 1, which is perpendicular to the plane of A and B. That means that if the vectors A and B are defining a plane, okay, that is the same plane in which, for example, the parallelogram or the triangle formed by A and B lies in. So that particular plane. So then n cap is a unit vector which is perpendicular to that plane. Yeah, Piyush, that is as per the definition. I've been telling again and again. Okay. That is as per the definition. All right, so let's come back to this. No, two vectors always define a plane. They cannot be in different planes like that. Okay? So I'm coming to this. So let's understand this with an example. So, for example, if this is the vector E and this is the vector B, then you can see that A and B always define a plane. The only time that A and B don't define a plane is when they are parallel to each other or anti-parallel to each other. Okay. So, you have to understand something over here, that if we have what we call non-collinear vectors A and B, they will look either like this or they will look like this. They might be making an acute angle or they might be making an obtuse angle. But the term non-collinear means they don't lie along the same line. Yes. So non-collinear means not along the same line. Okay. So the important thing here is that whenever we are looking at two non-collinear vectors, if two vectors A and B are non-collinear vectors, they are non-collinear vectors. The non-collinear also means they don't lie on the same line. Okay. Then they define a plane. They always define a plane. That is the same as the plane of the parallelogram or the triangle formed by the two vectors. You can see that in both the cases I have drawn above, this vector and this vector, they will define a parallelogram like this. So that's a planar figure. Or they will define a triangle like this. For them head to tail triangle. Whereas if A and B are two collinear vectors. Okay, so collinear का मतलब क्या हो गया? Means or they lie along a common line. Okay. So example of two vectors which are collinear are this and this. Like you have one vector like this, and let's say you have another vector which is like this, or you have one vector which is like this, and another vector which is opposite in direction. So these are examples of what we call collinear vectors. If E and B are collinear, then theta between them is either 0 or theta between them is 180 degrees. So they lie in a common line. That means they are either parallel or they are anti-parallel. Okay. Then they do not define a plane. Okay. So when you compare these two diagrams, you will understand that why in the case of non-collinear, they define a plane, Whereas, so don't worry, I'll take you step by step through this. But first, let's understand this whole business of collinear versus non-collinear. So forget about this for a moment. Okay? We'll come back to this definition. We'll come back just now. Right now, concentrate on this thing which I'm showing you here. That two cases, collinear vectors and non-collinear vectors. So जब भी हम दो vectors को compare कर रहे हैं, if they are non-collinear, that means they don't lie along a straight line, then they will always define a plane. Okay, just imagine you have got any two lines. Okay, so just a minute, I'll show you something. Yeah, so just concentrate here for a moment. Okay, so if you've got two vectors which are not collinear, like my two pens over here, two lines which are non-collinear, then they will always define a plane. They will always lie in a certain plane. Okay, whether they are like this at an acute angle or they are like this at an obtuse angle. But as long as they are not lying along a straight line, they always define one plane. They lie in one common plane. Whereas the moment your two vectors are like this, they are lying along a straight line. They are either anti-parallel like this, lying along a straight line, or they are parallel like this, lying along a straight line. Okay. Now there are infinite number of planes because a line, okay, a line lies in infinite planes. You can is what we mean by collinear versus non-collinear. Right. Right. So hope you're getting the screen again now. So coming back to this, you understand this from the paper diagram now. So the moment your two vectors are such that theta is, so non-collinear means that theta is not equal to 0 degrees or 180 degrees. Okay, so that means theta is either acute or obtuse. In that case, what is happening? They are defining a plane. So that was this diagram that I was showing you earlier. That they are defining a plane. So this is this case. Non-collinear का मतलब ये हो गया. See, there are two lines which are not. There are two linear objects which are not lying along the same axis. So here they are at an obtuse angle, but still you can see that you can define a sheet of paper which contains both the lines. Okay, so they are defining a plane. If they are at an acute angle, they are like this. So again, you can define a sheet of paper which is containing both the pens. Okay, but there's only one unique sheet or one unique plane. But the moment they are lying collinear, that means they are either parallel or anti-parallel. That means they define one straight line. They're not defining one plane. So there are infinite sheets of paper that you can draw in such a way. There are infinite sheets of paper that will be having this thing, that will be containing that line. So that means they don't define a unique plane anymore. There are infinite planes in which they lie. So that is what we meant by saying that non-collinear vectors define a plane. Okay, so that is the first part. Whereas the moment you talk about collinear vectors, they are now a single line. They form a single line. So there is no unique plane. There are infinite planes that contain them. Okay? So the moment you have this situation that they are collinear vectors, that is, okay. So now there is no unique plane for A and B. Okay. There are infinite planes that contain the line formed by vectors A and B. Okay. So that is why we say that they don't define a plane. They do not define a plane if they are collinear. Collinear means along the same line. Whereas going back up, if they are non-collinear, then they define a unique plane. Okay. So in that case, what happens? The vectors A and B define one unique plane. There's one and only one plane in which they lie. That is what we mean by saying collinear versus non-collinear planes. Okay. So I'm just going to leave you with a minute to just write down this definition of collinear and non-collinear and how they define a plane versus how they don't define a plane. Then we will go back to understanding cross products and how they are related to this. So hope all of you understood now. Agar two vectors, they are forming the sides of a parallelogram or a triangle, then that triangle is a planar shape. No? It lies in a two-dimensional plane. You can define a sheet of paper in which that triangle lies. But the moment the two vectors are along a straight line, you cannot define one sheet of paper alone. There are infinite sheets of paper, or there are infinite planes in which that vector might be lying. So that's where that concept comes in. Okay, so understood the definition of non-collinear. Yes, matlab any two-dimensional plane, like the tabletop of the table on which you are sitting, or the floor, the wall, any such thing is a two-dimensional plane. A plane is also sometimes called a lamina. In geometry, we also call the plane as a lamina. So now collinear का मतलब क्या हो गया? Collinear is that they should be lying along one straight line. So the two vectors we are talking about, they should be lying along one straight line. So if the two vectors we are talking about lies along one straight line, okay, so hope you understood the difference between laminar and non-laminar, or collinear and non-collinear vectors. Okay. So now let us come back to the definition of A cross B. So coming back to the definition of cross product. So the first thing we'll understand is that AB sin theta n cap. So the first thing is that the cross product operation gives a vector quantity. Okay, such that its direction is along the unit vector defined as n cap, where n cap is perpendicular to both A and B. Okay. So for example, if vector E is like this and vector B is like this, then the parallelogram formed by them is like this. So in this case, n cap will be perpendicular to the plane of the parallelogram shaded. So it will be given by that kind of direction. Understand? Okay. So just note down this point first. That the cross product results in a vector. So this operation results in a vector quantity, and that vector quantity's direction is such that it is given by the unit vector n cap, where n cap is perpendicular to that plane of that parallelogram, which is formed by A and B. So in this case, yes, with n cap is coming out of the plane of the figure, but sometimes it can also be going into the plane. So that is what we'll understand next. How we decide कि n cap मेरे figure के बाहर आ रहा है or it's going straight away from me. Okay. So for that we make use of the right hand thumb rule, okay, which I will come back to. To answer your question, you will always know when to use cross product and when to use dot product, because हमारे physics में जो definitions है, they will be in terms of dot or cross. For example, when we come to the chapter of work done, we'll see work done by a force, work and energy. When we come to, we'll see work done by a force is defined in terms of dot product, so there won't be any confusion. Whereas when we come to a chapter like rotational mechanics, we'll see that torque is defined by a cross product. It is as per the definition of the physics chapter, quantity in that particular chapter. You will automatically know whether you are using dot product or cross product. So don't worry about that thing right now. That is something that will come ahead. Abhi, what you have to concentrate, what is the definition of dot product, what is the definition of cross product. And you know very well that whenever we are using this symbol, that means we are using dot product. So iska definition kya hai? This is AB cos theta. Whereas whenever the symbol we are using is the cross sign in between A and B, this one here, then you know that this is the cross product and it is defined by this. So for the moment, this is the only thing you have to understand, that there are two different things. Dot product is something else, cross product is something else. Okay. Now the next thing is n cap is given by what we call the right hand thumb rule. Okay. So that means that for A cross B, what you should do is orient your right hand such that your thumb points along the vector E and your fingers point along the vector B. Okay. Then the direction to which the palm faces, that becomes the direction of n. So for example, now just let's practice this on the computer screen only. So whatever screen you are watching it on, suppose this is my vector E and this is my vector B. So this is vector E, this is vector B. Now you have to place your palm such that your thumb is pointing along A and your fingers are pointing along B. And so you have to place your your palm on the computer screen such that that is happening. So you can see that here E cross B. So when you face your hand like this, it should be like this. So this is your palm. This is along the direction of E. This is along the direction of B. So you can see that. So E cross B is coming out straight from the screen. Got it now? Understood now? So you have to just place your thumb along the vector E and your fingers along the vector B. So your hand will have to be oriented in such a way that your palm is facing straight towards you. is coming straight out of the screen. So that means the direction of the vector A cross B or n cap is coming straight outwards towards you. Okay, let's practice this with another one now. Now in the next one, let us say my vector A is over here and my vector B is over here. So now this is the direction of A and this is the direction of B. So this time you see you will have to place your palm like this. So when you place it like this is your thumb. These are your fingers. Okay. So you see that your knuckles are here. This is the knuckle side because fingers are pointing along B and your thumb is pointing along E. Okay. Yes. So here your hand is such that the right hand is placed such that your palm is facing away from you. From the screen or into the screen, you can say. It is into the screen. Not outwards of the screen, but into the screen. So it's not away from the screen, rather it is away from you. Away from your face, into the screen. Okay. So here, so therefore, A cross B or n cap points into the plane of the screen. Okay. So this is how we make use of what we call right hand palm rule to determine the exact direction of n cap. So now you can write down this definition and then we'll come back to those examples. So first of all, okay, you know that n cap will be perpendicular to the plane, but perpendicular can be maybe दो चीज हो सकता है. It can be into the plane, it can be out. Do we know? Okay. So for the direction of n cap, okay, it can be into the plane or it can be coming out of the plane. So how do we determine which one of the two it is? Okay. We determine it by this particular rule, which is called the right hand thumb rule. So just note down the rule first and then we'll go through the two examples once again and you will not have any difficulty understanding. Okay, so let's go over this whole thing once more. Okay. Yeah, the voice will be okay now. Okay, the voice will be fine now. So n cap points in such a way that if you're doing the operation A cross B, then you have to point your right hand thumb along A and your right hand fingers along B. In that case, whichever way your palm is facing, that becomes the direction of A cross B. So in this case, in the first example I've shown over here, we will do more examples. If you place your right hand such that your thumb should be pointing along the vector E and your fingers should be pointing along the direction of B, okay, then you see you'll have to face your hand just the way I've drawn it over here. You have to place your hand towards Z. Whichever direction palm point कर रहा है, वो क्या direction है. So in this case, your palm is facing towards you. That means where is n cap? It is coming out of the plane straight towards you. Okay. So hope this first example is clear. So just note this down for a second. I will reconnect to the internet once. Okay, I'm having some internet issues. I'll just reconnect. Okay. Yeah, thanks for pointing out. The recording was paused for whatever reason. I got disconnected. Now the recording is on again. So for the sake of the recording also, I'll just go through this question once more. So yes, now all of you got this correct. So this is going into the plane. Okay, this is D is into the plane and E is coming out of the plane. Okay. So since we lost a bit of the recording because of my connection loss, so I'll just take you through this again. So we were looking at these examples. So this is a further example of that only. So in each of these cases, we had to determine whether the unit vector representing A cross B or the direction of A cross B is into the plane or out of the plane. So here we saw it is going into the plane. In case B, we saw it is again going into the plane. In case C, we saw it is coming out of the plane. And again, in these two cases, D, we saw it is into the plane and E, it is coming out of the plane. Okay. So I think everybody is clear with this now because I've got most people, in fact, almost everybody who's given me the correct answer. Piyush is asking the question, what is the use of n cap? The use of n cap is to give the direction vector. Okay, so any vector, when we express it as a vector, as let's say some magnitude into a unit vector. So what is the use of each? This one is the magnitude of the vector. And what is the use of n cap? It is the direction of the vector. Okay. So similarly, in cross product, the use of the n cap is that it gives us the direction of the vector. It gives us the direction. Okay, so now let's come back to the properties of cross product. So we saw the first 2 points. First, we saw that it's a vector quantity. And second, we saw the use of right hand palm rule. So these two we saw. Now let's come to the third point. What is the magnitude of A cross B? So that is mod of AB sine theta n cap. So that is nothing but AB sine theta. Okay. The magnitude of A cross B is nothing but AB sine theta. Now this has a significance. Okay, and that significance is something very interesting. So if you visualize any two non-collinear vectors, A and B, such that the angle between them is theta, then you'll see that this altitude is nothing but B sine theta. So B sine theta is nothing but this, and A is nothing but this. Okay. So that means that magnitude of A cross B, जो कि AB sin theta है, that is nothing but base into height of parallelogram formed by A and B. Okay. So that is nothing but this area. So that is nothing but it is the area of the parallelogram formed by vectors A and B. Or you can say that it is double of the area of triangle formed by A and B. But better way to remember it is that it is the area of the parallelogram formed by A and B. So in the last part we discussed about the direction of A cross B, how we get n cap. Now this third point we talk about the magnitude of A cross B. So what does the magnitude of A cross B become? It becomes the area of the parallelogram formed by the vectors A and B. So that is the significance of the magnitude. Arey Piyush, you are going on asking the same question here. If we took the magnitude of A cross B as AB cos theta, it would be the same thing as dot product. No? It's a different operation, beta. Don't connect it with dot product. Dot product is a different operation, cross product is a different operation. Dot product का definition ऐसा होता है that it is A into B's component along it. So it is AB cos theta. Whereas cross product का definition ऐसा होता है that magnitude is the area of the parallelogram. So it has to be AB sin theta. So I'm explaining to you the significance, why it is AB sin theta. Because now it represents what? It represents the area of the triangle. Okay, so now we understood both the magnitude and the direction of the cross product. The magnitude is AB sin theta, which means it is the area of parallel that this is given by unit, basically according to the okay, people. So hope you're clear about this sense. Yeah, so let's get down to doing some questions. Okay, so just work this out, people. Each of them is of magnitude 30 degrees, magnitude 10 units, and the angle between them is 30 degrees. So how much will be A cross B's magnitude, and what will be the direction? Will it be going into the plane or coming out of the plane? Yes, very good. Yes, Aditya, correct. Dhruv, correct. Yashmit, correct. Very good. Sudeep, be careful. Sin 30 कितना होता है? Vyapi, correct. Yujit, correct. Raj, correct. Okay. So just apply the formula, people. Nothing more you have to do. So as far as mod of A cross B has to go, it is sin theta. Okay. So that is 10 into 10 into sin 30. So it is in fact 50, and whatever unit this was, that unit square. So that is your mod A cross B. And direction of A cross B, in this case, will be into the plane. That you can again see by right hand rule. Okay, just work this out also. Okay, people. So unfortunately, I'm having some trouble with the internet. So just complete this question. question, I will in the meantime try to use a different line to join. Because so just complete this problem. By then I'll try to connect using a different line. So just give me a minute. Okay, so let's hope this works better now. Yeah, so meanwhile I've got a lot of answers and actually I have lost track of everything. Okay, a lot of answers I've got. Let me verify. Okay, so in the second one I should be getting, so let me do each of these for you. So in this one, magnitude of A cross B should come out to be 20 into 25 into sine 127, okay, which is the same thing as 500 into sine 53, which is the same thing as 500 into 4 by 5. So it should be 400 square units, whatever unit was. Okay. So this should be A cross B. Remember, we'll use for second quadrant sine 127 will be equal to positive of sine 180 minus 127. So that is sine 53. That is 4.5. So this is what we are using over here. And the direction you can see is coming out. Outwards. Okay. You can get that from the right hand rule. Right hand palm rule, if you apply, you will get this. So this should be the direction and magnitude for B part. So I'll just minimize the whole thing again so you can see the whole thing. So A was 50 and going into the plane, B is now 400 and coming out of the plane. Okay. Let's come to C and D. So C में क्या हो रहा है? It's very easy. It's 90. So A cross B's magnitude will just be AB sine 90 degrees. So that is directly AB. So it will be 300 and direction will be going into the plane. And you can use the right hand. Oh, sorry, it's coming out. My mistake. Direction is coming out. Outwards. Okay, good. So that seems fine. Yeah, so I can see that yes, Smith has got it correct. Ranak, Mahek, Aditya, okay, all of you got it right. Vyapi, Piyush, Dhruv, okay, correct. Okay, now let's come to the third one. So here you can see, now third one is a little awkward. How you will place your palm, you'll have to twist your hand a little bit like this, like I'm doing in the screen, see. You have to twist your hand like this to understand how A cross B is lying. You have to twist it and keep it like that, A cross B. So, but still it will be out towards you. Okay, so it is outwards. And the magnitude will be 10 root 3 into 20 into sine 60. Yes, Yashmit, that is the answer which I have placed. So hopefully all four answers are there on the board. This is 300. Okay, I'm coming out. This is 300 and outwards. This is 400 and outwards. And this was 50 and into the hey, the last one is also outside only, better. Last one is quite awkward. Okay, how you are placing it. So let me just try and demonstrate the last one for you using. It's a little awkward. Okay. So don't know if you can see on the sheet. Yeah, just about see. Okay. So if it is like this, then you'll have to place your hand like this. Okay. So A over here, people, this diagram. Yeah. A is pointing downwards, and B is pointing like this. So in order to get A cross B now, you have to point your thumb downwards and your fingers like this. So where the palm is pointing, you can see it's pointing outwards towards me. That is why it is coming out of me. Alright. So that is me struggling with video lectures, okay. But fine. Okay. So hopefully all of you understood. It will be giving, yeah. And Sisti, yes, your point is correct. Where when we have parallel or anti-parallel vectors, your cross product will become 0. Which makes sense because the area enclosed is also 0. There is no, so we have an example where, how many examples we have done? 4 examples. So let's look at this next one. Now in this, suppose the vectors A and B are like this. The angle between them is 0. Okay, so you can see over here that it doesn't matter what their magnitudes are. Okay. Magnitude of A cross B will just become AB sine 0, that is 0, okay, because they do not form any parallelogram. So the area is 0. So that is why the magnitude of A cross B becomes 0. Similarly, if they were anti-parallel also, it would be the same thing. If they were like this also, in opposite directions also, it would be the same thing. This angle is 180 degrees also. Okay, so that is 0. Because sine 0 is equal to sine 180 is equal to 0. So in that sense, you can just understand it's like the reverse of what we do for dot product. Okay. Dot product has maximum value when they are parallel and is 0 when they are perpendicular. Cross product has maximum magnitude when they are perpendicular. Sine 90 is 1 and minimum when they are 0 or 180. Yeah, I mean, so the final answer, Yashmit, in those questions was this way only. The way I've written over here, that it's 400 units square and direction pointing outwards. 50 meters unit square and direction pointing into the plane. that is how we'll have to signify. All right. Okay. Now let's do another couple of examples. Magnitude of A is equal to magnitude of B is equal to 10. Okay. And magnitude of E plus B is 10 root 3 units. So find mod of A cross B and A dot B. And let's do another one. Just try this out, people. So now you have to be alert to these type of questions also. Yes, Atharva. If you're doing x cross y, whichever vector you taken first, your thumb will be in that direction, and whichever vector you taken second, your this will be in the other direction. May I correct? Others, I'm still waiting for the correct answer. No, still not getting the correct answers. Nope, still not. Only one person has got. Yeah, Harshvardhan. See, basically what you have to do is now, ये जो information है अपने पास, this information and this information, from this you can figure out that what is theta, okay. And then this just becomes AB sine theta, that is 100 into sine theta, and this just becomes AB cos theta. Yeah, Vyapti correct. Yeah, Smith correct. Good. Austin correct for the first one. Mehak correct for the second one. Devansh correct. Okay, now people are getting it correct. Okay, so in the first one you'll see that if mod A is equal to mod B is equal to 10 and A plus B's magnitude is 10 root 3, it means that root of A square plus B square plus 2AB cos theta is equal to 10 root 3. So that will show you that is this. So you can cancel the 10 and square both sides or whatever. This will show you that cos theta is half, or theta is 60 degrees, or sine theta is root 3 by 2. Okay. Therefore, the magnitude of A cross B is AB sine theta is 10 into 10 into root 3 by 2. So that is 50 root 3 units squared. And A dot B, which is EB cos theta, is 10 into 10 into half. So that is 50 units square. Okay, so that is the first part. Now you apply the same kind of logic for doing the second part also. Those of you who've done the first and second also do one more. Yeah, Shivam correct, Ranak correct, Sanya correct. Hey, Sanya, you have to check the B part. Yeah, Dhruv correct now. Correct, Atharv. Yojit correct. Okay, so now I'm working out the second question for those of you who have not yet got it. So 15 and 20 and A dot B is 0. Okay, so that part. So always remember, this means that A and B are perpendicular. If dot product is 0 means that theta is equal to 90 degrees. So further that means that magnitude of A cross B is AB sine 90, which becomes 300, okay, and magnitude of A plus B becomes root of A square plus B square. Become 24. Okay. So this is the second question. Yeah, I'll minimize again for the third question. Just give me a moment. Let others finish with this. Dhruv, correct. In this case, beta, we can't tell the direction because we have no information about the direction of A and B. Okay. So that's why everywhere in the question only magnitude has been asked. But अगर मैंने diagram में direction दिखाया होता, then I would have asked, okay, the direction has to be there. So this is example 3 now. Yes, Yashmit, correct. Okay, so let me pick up the third question also now. So 12, 16 and this is given. A plus B is equal to A minus B. Now, by now you should be practiced enough to know that if A plus B has the same magnitude as A minus B, it means that theta is equal to 90 degrees. Now, how to remember this one is geometrically. You remember, okay. Equal diagonals, equal length diagonals किसके होते हैं? rectangle K. What sort of a parallelogram has equal length diagonals? Only a rectangle. So theta is equal to 90 degrees. Or you can also go formula wise, that is root of a square plus b square plus 2ab cos theta equals this. So now square both sides and solve. So ultimately you will get cos theta equal to 0 or theta equal to 90 degrees. So one way or the other, this should be a very apparent thing to you. The moment you see a plus b has the same magnitude as a minus b, by now you should be well practiced enough to come to this step directly. Right, and once you are at this step, now know that therefore E cross B का magnitude AB sin 90 हो जाएगा. Yeah, in this case 192, and A dot B will become 0. So this is just to give you an example of the indirect type of questions that can be asked. Okay, now let's come back to a few additional properties of cross product. Okay. So I hope these examples are clear to all of you. And anyway, once later when you're revising the lecture, just go through the notes. Yeah, yes, you can say these. Many of these questions can be done orally also. But in the exam, you have to be careful not to make a mistake. Okay. So now let's come to some more properties of cross product. One very interesting property is that A cross B, को अगर मैं compare करूँ with B cross A, I'll see that they are not the same. They are this. Okay, let's understand why. Because A cross B is AB sin theta n cap. Okay. Now suppose in my diagram A and B are like this. So n cap का direction इस case में क्या हो जाएगा? N cap will be, now use your right hand rule, so it will be outwards, it will be coming out. Okay. Now what about B cross A? B cross A will be BA sin theta, but into some other unit vector. No? Now what will be this unit vector? N prime. Now what we'll have to do, this time to get n prime, you have to reverse your law. You have to put your thumb along B and your fingers along A, because you're doing B cross A. Na? So इसका direction क्या हो जाएगा? उल्टा हो जाएगा. Okay, so in this case now, so for B cross A, you have to put thumb along B and fingers along B. Whereas for A cross B, you're doing the reverse. For A cross B, you are putting thumb along A and fingers along B. That's why you are getting n cap outward. Now this time when you do this, your n prime cap will be into the plane. Just do it. Okay, so you place your thumb along B and your fingers along A, so ulta ho jayega. Okay, so that's why you can see that. So if you put this information together now, you can see that n prime cap is opposite to n cap. Okay. So that means A cross B has the same magnitude as B cross A, which is AB sine theta or BA sine theta, one and the same. But as vectors, this one and this one have opposite directions. B cross A and A cross B have opposite directions. Okay. So that is why finally as a vector equation we write that A cross B is equal to minus of B cross A. Okay. So this becomes a very important operation. So this becomes important to understand. Okay. So this is the first of the properties that we are studying, that A cross B is in fact not equal to B cross A, it is minus of B cross A. So they are, it is what we call a non-commutative operation. Okay. Why? Because A cross B cannot be said to be equal to, it's not equal to B cross A. It is minus of B cross A, so it's not equal to B cross A. So that's why it is non-commutative. Dot product, you'll remember, was commutative. Addition of two vectors was commutative. But cross product is non-commutative. Subtraction of two vectors is also non-commutative. B cross A is negative of A cross B. A cross B is negative of B cross A. It's one and the same thing. So their magnitudes are equal, okay, but because their directions are opposite. So Yasmin, just to go with this again, देखो यहाँ पे अगर the vectors are given like this. Now when I'm doing the operation A cross B, so I'm writing A into B, A cross B. So my thumb should be along A and my finger should be along B. So that is why when I did this for these two vectors, I placed my thumb along A and my fingers along B. My palm was pointing outwards. So the direction of n cap, unit vector of A cross B, क्या हो गया बाहर की तरफ. But next when I'm doing B cross A, so for the direction what I should do for n cap, I should put, because first I've written the vector B, then the vector A. So now I should put my thumb along B and my fingers along A. Whichever is the first vector in the notation, that one should be where your thumb is, and whichever is the second coming after the cross sign, that's where your finger should be. So when you write B cross A, the relationship ulta ho gaya. So now your palm points into. So now when you compare these two vectors, A cross B is some vector and B cross A is some other vector, they have the same magnitude, but they have opposite directions. This one is pointing out of the plane, that one is pointing into the plane. So that's why we say that one is negative of the other. Okay, so when you are applying the right hand palm rule, just remember that whatever two vectors you add into. So for example, if you are doing, let's say, vector E cross F. So in the notation, whichever one you've written before the cross product, that is where your thumb should point. Whichever vector you've written after the cross product, that is where your finger should point. And then n cap for this vector, the cross product, points in the direction where your palm is pointing. Yes, addition is commutative, as you know. Addition and dot product are commutative, whereas cross product and difference of two vectors become non-commutative. Just like, you know, we can say A cross B is not equal to B cross A. Like that, we can say A minus B is not equal to B minus A. So these are both non-commutative properties or non-commutative operations. Okay, people, so hope this is clear so far now. Just a moment. Alright, now let's move on to another property of cross product. So this was the first property we saw. Now second property, any vector cross product with itself is a null vector. This is very obvious because sine 0 is 0. So E cross E will be E square sine 0 in caps. See, if any operation is such that then it is commutative. Okay. So operation of A with B is equal to operation of B with A, then it is commutative. Whereas if operation of A with B is not equal to operation of B with A, then we say it is non-commutative. In this example, I am talking about a scalar operation, but if this is vector sign, then this becomes a vector operation. But whether it is vector or scalar, if one thing operated on the other is equal to the other thing operated on the first, then we say that particular operation is commutative. And if it is not equal, then we say it is non-commutative. Okay. So that is the meaning of commutative versus non-commutative. In scalar algebra, for example, multiplication is commutative. 3 into 1 is 1 into 3. Or 1.6 into 1.2 is 1.2 into 1.6. But division is definitely non-commutative. 5 by 6 is not equal to 6 by 5. So scalar operations also have, some of them have property of commutativity, some of them have non-commutative in nature. But here we are talking about the vector operation. Okay, so now coming back to this, the second operation, as you can see, it's this. Okay. So now, and the third operation we'll see is distributive. So A cross of B plus C can be simplified as A cross B plus A cross. That means cross product is a distributive operation. So hope this is clear so far, people. Yes, scalar product is also distributive. We have seen all that already. Now the next thing, very important, we'll understand about cross product in component form. Okay. So first let's understand the relationship between I cap, J cap and K cap. Okay. Now this is again where something where the right hand palm rule comes into the play. Now again, you have to understand the three-dimensionality. This plane, which is say the XY, the Z plane. Okay. So as you can see, I have drawn this consistent with the right-hand system. So now it will also be consistent with the cross product system. So according to this, you will see I cap cross J cap will be equal to k cap. But j cap cross I cap will become minus k cap. Okay. Just work this out. Imagine this in 3D. Now place your thumb along the positive x-axis, your fingers along the positive y-axis. So you'll see your palm is pointing along the positive z-axis. Okay. So you can see that I cross j will be magnitude of I, which is 1, into magnitude of j, which is 1, into sine 90. Okay. But what will be the direction? It will be k cap. So when you do mod of I cross j, it is 1 into 1 into sine 90. So its magnitude is unity. That means it also gives you a unit vector. But direction, okay, by right hand palm rule, it will be along the positive z-axis. Okay. So that is why this is like this. That is why this. And then this is just the property. A cross B is minus of B cross A. So J cross I should be minus of I cross J. Okay. So that is how this becomes consistent with the right-handed system. Because we have drawn the coordinate frame also according to right-handed system. Therefore, it is consistent with our right-hand palm rule of cross product. So you were asking that day when we are discussing about right-handed coordinate system, why we define like this. So one of the reasons is so that it is consistent with our cross product rule also. Okay, hope this is clear, people. So just make a note of this carefully. Okay, so now let us see this, how to write cross product in two-dimensional component system. Okay, therefore, for two-dimensional vectors A and B, suppose they are in the xy plane. A cross B will become, replace A with its components. Cross product with Bx I cap plus By j cap. Now see, when we expand this next using the distributive property, we keep in mind that I cap cross I cap kitna hoga? 0 hoga. Because remember, any vector cross product with itself is 0. J cap cross j cap kitna hoga? Wapas it will be 0. But what about I cross j? We just saw it is positive of k cap, and j cross I is what? It is minus of k cap. So we'll keep this in mind when we open this bracket. Okay, so you'll see that we have got ax bx into I cross I, but I cross I is going to be 0, so this term will not come finally. Plus ax into by. Now this term is going with I cross j, so this will come with a positive k cap. Okay. Then plus we have ay bx going with j cross I, and finally, so let me just make some place here. Yeah, right. So plus ay into by. This is going with j cross j. Now this term is 0 and this term is 0. Whereas this term here is positive of k cap, and this term here is negative of k cap. So finally, what is my A cross B becoming? It is Ax by minus Ay bx into k cap. So this is like a formula we develop now using the properties of cross product. See what properties I've used. I've used distributive property, and I've used the relationship between I cap and j cap for cross product. This relationship that we do earlier, this was as per the right hand rule. This one we have used, and we have opened that bracket using this property, the distributive property. So using this distributive property and the right hand palm rule, I've come up with a formula which tells me that when I have two vectors A and B in the xy plane, so they're in two-dimensional component system like this, their cross product should be a vector perpendicular to them. So they should be either along plus k cap or minus k cap, and this is how we'll get the formula for it. So there's a shortcut way of remembering the formula also, and I'll discuss that with you. But first, you note down how we get the formula in the first place, and that is through this. So we can just start by noting down from here, and then we'll come to this. Yeah, I'll scroll down. So, but before that, how we got the first step is by using distributive property. So cross product is distributive. So it has the property of something like this, that x plus y, cross product with A plus B, will be x into A plus x into B plus y into A plus y into B. So just like this, here also the distributive property applies. So the first term becomes Ax I cap cross product with Bx I cap. So that becomes Ax and Bx are constant. So take them out. So I cross I. Then second term is this cross product with By j cap. So that's this term. Then the third term is this thing cross product with this. So that's this. Then the final fourth term is this cross product with this. So that's this. Okay. Which one? This one? This step? This is the definition. This is the definition of right hand rule. Yeah, so that's what I'm saying. It's as per the definition of right hand rule. I cross I is 0 because any vector cross product with itself is 0. Whereas you'll remember any product dot product with itself is equal to its magnitude squared. So this was 1. J dot j was 1. Because why? This is defined according to cos. This is defined according to sine. So cross product with self becomes 0. Whereas dot product with this vector was 0. Whereas here, what is cross product? It's k cap. So it's exactly opposite of dot product. हाँ तो वही ना बेटा उसको component form में लिखा है ना. I'm telling you that the vectors A and B are 2D vectors in xy plane. So in component form, the vector A will be written like this, no? X component I cap plus Y component J cap. This we are just replacing the vector in its component form. Okay, so that is clear then. Okay. Okay, now for the shortcut formula to remember it. So develop a shorthand notation for this formula. We use something called determinant of a matrix. Okay, and in this case, a 2 by 2 matrix. So first, I mean, you would have studied this in 9-10, but I'll just do a quick review. So a 2 by 2 matrix is an array of 4 numbers, like this, let's say. Or you can just say it is A, B, C, D, whatever, like this. So any matrix is rows and columns. So a 2 by 2 matrix has 2 rows into 2 columns. So it's an array of 4 numbers. Okay. Now determinant of this matrix is given by this operation. It is given by product of these 2 numbers. Let's say diagonal 1 and product of these 2 numbers is diagonal 2. So it is d1 minus d2, or it is given by the formula a11 a22 minus a12 a21. So just write down an example then. So example, determinant of, I'm just taking something random, let's say 3142 is equal to 3 into 2 minus 4 into 1. So that is 2. Alright. So just write this down first in case you are not familiar with this from before. Then we'll come back to how we use this. So this is not related to vectors just now. This is just the general concept of determinant of a 2 by 2 matrix. Okay, so just write this down first. Then we'll see how we can make use of that to develop a shorthand notation for the cross product. Okay, so just as a practice, do one more question. So find the determinant of this. How much is the determinant of this? Correct. Very good. Should be 11. So this will become 2 into 3 minus of, now not to forget the algebraic sign of the term. So minus 1 into 5 will become 11. Correct. Okay, good. So I think you people are mostly familiar with this, so should not be any problem. Very good. So now we can see that we had written the formula earlier that in 2-dimensional system, A cross B had become this thing, Ax by minus, yeah, just a moment, I'll scroll up, Ay bx times t cap. Okay. So we can also write that, so the vector A is, and the vector B is bx I cap plus by j cap. You can also see here that this term that we had written above is like the determinant of this 2 by 2 matrix. इसका पहला रो में क्या रहेगा, A के components रहेंगे और दूसरे रो में क्या रहेगा, B के components in correct order, Bx and By. And because these are in the xy plane, so this has to be k. So next step, this becomes ax by minus ey bx. So this is your shorthand trick of remembering the formula for this. The formula will be a determinant of a 2 by 2 matrix such that 2 by 2 matrix, तो यहाँ पे क्रॉस प्रोडक्ट में जिसको भी हम क्रॉस के पहले ले रहे हैं, फर्स्ट वेक्टर ई, उसके कंपोनेंट्स क्या आ जाएंगे, फर्स्ट रो में आ जाएंगे. And whichever vector we have taken after the cross product, the second one, that one's components will come in the second row. So that determinant to k cap becomes the cross product. Shorthand is then you don't have to remember this formula. No? You have to just, so if, for example, Raj, if I just give you a vector like this now, E is equal to I cap plus 2j cap, and B is equal to, let us say, 3I cap plus 4j cap. Now ask you what is A cross B. You can do this calculation very quickly now. You can just write this determinant 1, 2, 3, 4 k cap, and that's it. You're done. So it's 4 minus 6, so minus 2 k cap. So you don't have to remember the formula ax by minus a by bx. It's a sort of memory trick to remember the formula. And when we extend to 3D, you'll understand why it's a very useful shortcut. Okay, so that is the determinant concept. Okay, this was the simple example we did. Now the example with a vector. So first of all, the formula in determinant terms becomes like this. All right. So this is clear, I hope. So in this case, you know, this vectors, if I ask you, the A cross B ka n cap kya hai? What is the unit vector of this? So you can see this is minus 2k. So n cap for it is actually minus k. The unit vector for A cross B's direction is actually minus k cap, and mod of A cross B is how much? It is just 2. You won't say mod is minus 2, no? We'll say mod is 2, but the direction is along minus k cap. So the n cap is minus k cap. Right? So this is clear. So as a very simple example, you will see that if I just ask you what is I cross j from this, you know it is k cap. But you can also think of a vector A which is I cap, a vector B which is j cap. So A cross B should become 1, 0, 0, 1 k cap. You can see that is k. Whereas if I ask you what, for example, what is 2j cap cross I cap. Okay, so again you know that this is 2j cross I, which is minus 2k cap. Okay. But if you write it this way, 2j cross k, cross I, formally you can also write it as 0 to 1 0 k cap. So it is minus 2. It's a very simple example of application of this. Okay. Or for example, if I give you a diagram where vector A is like this, vector B is like this. Now let us say vector A has a magnitude of 12 units, vector B has a magnitude of 10 units, and the angle is 37 degrees. Okay, now I ask you to find A cross B by formula or definition, and B using I cap J cap notation. So work it out by both the methods now. Yeah, 72. And what about the direction? Yes, correct. Answer is correct. And what will be the direction? Coming out or going in? Coming out. Very good. Okay. So if you go by the formula method, the definition method, you can see that right magnitude of A cross B, AB sine theta. So that will be 72 whatever units square. Okay. And the direction by using your palm rule will be outwards, out of the plane. By using your right-handed palm. Okay. Now let's try the same thing by component method. In the component method, what we'll do is we'll convert A and B to components. So for that, we'll define some x-axis and y-axis. So most convenient for us will be to define the x-axis along A and the y-axis along this. So if I have taken a system like this, okay, so then in my system, the vector A will just be 12 I cap, and the vector B will just be 10 cos 37 I cap and 10 sin 37 j cap. The vector A will be written as 12 I cap. The vector B will be written as, so B's x component is 10 cos 37, so that is 8, and B's y component is 10 sin 37, so that is 6. Okay, so this will be written as 8 I cap plus 6 j cap. Okay. So A cross B will become 12086 k cap. So you can see that it is 72 k cap. Now see, this is giving me the same information that one is giving, because you know that k cap is coming out of the plane. When I've drawn x and y the way I've drawn over here, so k cap is the unit vector coming out of the plane. यहाँ पे mod of A cross B क्या हो गया? It is 72, and n cap क्या हो गया? Plus k cap. So it is coming out of the plane. So it's exactly the same information that I'm getting from there. So this is the second method of solving the problem. Okay, people, so hope this is clear to everyone. Yeah, we'll do more problems, but now we have to also move to 3-dimensional. So, Just a second. So now cross product for three-dimensional component notation. So first of all, again keeping in mind our rectangular coordinate system, positive x, y, and z axis being like this. Mutually perpendicular planes. Okay, so we have not only I cross G is positive of k cap. So reverse of this is that J cross I is minus of k cap. Now look at this operation, J cross k, and see what it will give you. Point your thumb along the y-axis and your fingers along the z-axis and see where your palm is pointing. So just try this example by considering the xyz axis as the edges of the room in which you are sitting. You will understand. So it will be along positive I cap. So if you point your thumb along this edge and your fingers along this z axis, you see your palm is pointing along the positive x axis. So this will become positive I cap. And likewise, your k cross j will therefore become minus of I cap. If you point your thumb along the z axis and your fingers along the y axis, then you see your palm will be pointing into this plane. It will be pointing into this YZ plane. So it will be along the negative Z axis and negative X axis. Whereas if you take your thumb along Y and your fingers along Z, your palm will be pointing outwards from this YZ plane. So it is along plus I cap. Yeah. And similarly, if you take K cross I, now figure this out, what this will give you. Point your thumb and fingers in the proper direction and see what this gives you. Now try it properly. See, if you, this is like you're putting your palm on the floor, okay, and your thumb is pointing like this and your fingers are pointing like this. So your palm will be pointing straight upwards. This is the floor of your room, and this is the edge to your left, and this is the edge in front of you. Point your thumb along z-axis and your fingers along, so it will be pointing upwards like that. So this will be plus j cap. So this will give us plus j cap. There is the reverse of this, that is I cross k will give us minus. Right, so hope this is clear. Yes. So now there's a very easy way to remember this relationship, and that is called the circularity of ijk. If you just draw ijk in order like this and make a circular arrow like this, you'll see that whenever you go along the circle, you get a plus sign. So I cross j is plus k, j cross k is plus I, and k cross I is plus j. But whenever you go opposite to the arrow, you get a minus sign. So this simple diagram, or you can even think of it like this, x, y, z, because I, j, k, r. So whenever you're going along this arrow, you're getting the plus signs. Whenever you're going opposite, you're getting the minus sign. Good, yes, ma'am. Okay. So this is a simple trick to remember these 6 formulae like this. So now using this, we will develop a formula for cross product in 3 dimensions. So A cross B, को भी मैं अगर ऐसा लिखता हूँ, so A has all 3 components. This whole thing cross product with again these three components. So you can see we'll get quite a monster kind of expression, but it will be simplified a lot. So you'll get 3 into 3, 9 terms. So let's start by writing the first term multiplied with this entire row. So it is ax bx I cross I. So this term will become 0. Then we have ax by I cross j. Then similarly we have ax bz I cross k. Okay. Then let's come to the second row. So we have this thing cross product with all three. So ey bx j cross I plus ey by j cross j plus ey bz j cross k. And then we have the last term z multiplied with all three. So yeah, this becomes quite lengthy to look at, which is where again in the end our shortcut using matrix method will be very easy. So ez bx into k cross I plus ez by into k cross I, so k cross j. So write these down very carefully. Don't make a mistake while writing. So this will first simplify to this. So just write down this first and make sure all the terms are correct. Then we'll simplify this further using the unit vector cross product relations. Okay, people. So hope this is clear so far. So now see what will happen here. These terms, this one will be 0, this one will be 0, and this term will be 0. Okay. Whereas using the other relations, I cross j is plus k. But for example, j cross I here will give us minus b. Then I cross k will give us minus j. But j cross k will give us plus I. Then k cross j will give us minus I cap, and k cross I will give us plus j. So these are the unit vector relations which we have written above. So we're just making use of that. If you look at these unit vector relations above, just making use of that. Apart from the fact that cross product of any unit vector with itself is zero. Making use of these. So you can see that when we put all together, I cap के साथ कौन से terms आ रहे हैं? I cap के साथ ये term है, and so this term is there with I cap and this term is there with I cap. So to take I cap common, we have EY-BZ minus EZ-EY. I cap. Then J cap के साथ कौन से term है? There is this and there is this. So when you take those terms together, you have EZ-BX minus AX-BZ. And K cap के साथ कौन से term है? There is this term and there is this term. So there is AX-BZ. So dy ax dy minus ay bx. So we get a formula for cross product like this. Okay, so as it turns out, this is also the determinant of a matrix, but it's the determinant of a 3 by 3 matrix. So you can verify this formula when you're revising later, okay, but more important for us is how to write it as a determinant. The next thing, let us see determinant of a 3 by 3 matrix. So if I have this, so how do we calculate the determinant of this? We write it as E11 into the determinant of this matrix. Just remove 1 1. So you're left with, remove the first row and the first column. So you're left with this 2 by 2 matrix. The middle term comes with a minus sign. Now remove first row and second column. So remove this part. So left with these two terms and these two terms. So it is A21, A23, A31, A3. And then similarly, take the last term of the first row. So A13. So now remove the first row and third column. So you're left with this 2 by 2 matrix. So it is A21, A22, A31, A32. And then next solve this. So as you know, this becomes this. Then this becomes this. And this becomes this. So this is how we write the determinant of a 3 by 3 matrix. So this becomes the determinant of the above matrix by this kind of a formula. So next we will see that we can express the cross product as this kind of a determinant. Yeah, so I'm just explaining. So now you can see that A cross B can be written as a determinant of a matrix like this. Ax, Ay, Ez, Bx, By, Ez, which will simply become, take I cap outside and multiply it with the determinant of this 2 by 2 matrix. So remove the first row, first column. So we're left with Ey, Ez, Dy, Dz. Okay. Then minus sign for the middle one, you have to remember. So middle one is J cap. Now remove this middle row. So you're left with Ax, Ez, Bx, Bz, and then plus K cap. Now remove the last column. So you're left with Ax, Ay, and Bx, By. And when you solve this, you get the earlier formula that we got. So this becomes a very easy way of using the determinant to calculate the cross product. So you don't have to memorize that entire formula. So we'll do an example and you'll understand. So how to write it in terms of determinant? Write it as a 3 by 3 determinant or 3 by 3 matrix when the vectors are 3-dimensional. Where the first row is just the unit vectors ij. Second row is the components of this vector, the one before the cross product. And third row is the components of the second vector, the one after the cross product. And then just determine this. So for example, I have vector A, suppose, as 2 I cap plus j cap plus k cap. I have vector B, suppose, as I cap minus j cap plus 2k cap. I want to determine A cross B. So A cross B क्या हो जाएगा? So remember the step. is given in 3D. So I'll make a 3 by 3 matrix. The first row will be just the unit vectors. So I, J, K. Second row will be the components of A. So the components of A in order are 2, 1, and 1. So 2, 1, and 1. And third row will be the components of B. So they are 1, minus 1, and 2. Now I have to solve this determinant. So next step to solve this determinant. So next step. So first take I cap outside, and you're left with these terms because you've taken this row outside. This column is gone. So 1, 1, minus 1, 2. Then don't forget the minus sign in between, J cap. Okay, with this, remove this column. So left with these 4 terms. This, and this. So 2, 1, 1, 2. And then plus K cap. So remove this column. So left with this matrix. So that is 2, 1, 1 minus 2. And next step now just solve each of these determinants. So when you solve each of these determinants, you can see so this one will become 2 minus of 1. So that is 3 I cap. This will become 4 minus of 1. So that is, but with a minus sign, 3 J cap. And this will become minus 2 minus 1. So that's minus 3. So this will become my E cross. So you can see the steps get very simplified instead of remembering that very lengthy formula when we use the matrix, the determinant of 3 by 3 matrix. So magnitude will become 3D, right? But in component notation, it becomes this. No, but it will be minus 3 J cap because it is 2 into minus 1. This one is 2 into minus 1, minus of 1 into 1. So that's why it's minus. Yes, Viraj. The magnitude is root of x square plus y square plus z square. So root of 3 square plus 3 square plus mod of a cross b will just become 3 root 3. That is 3. So once you found the vector, it's easy to find the magnitude. That's the same formula. Okay, people. So hope you've understood this method. Now this is the this is where we conclude today's class. So now you will be getting a worksheet which will have both combination of cross product and applications of dot product. So this is going to be a little bit of a complicated worksheet. So next lecture will be mostly about discussion of the worksheet only. We are done with the theory of vectors. Yes, I'll be sending you the assignment. I'll put up the assignment on the website as well as send you the link to it. And also do questions from your module also. Apart from the assignment, also do questions from the module. Okay. So I'll also send you a list of priority questions to do from the module. But in general, now you should look at doing maximum questions by yourself also from the module. Apart from the questions I'm sending you, you should practice as many questions as you can. Okay. So hope all this is clear, people, and all the best. Yes. If anybody doesn't have the module, please send me a WhatsApp message. I will send you the PDF of the module on WhatsApp. Or you can send me your email ID on WhatsApp. So I will send you the module on email also. In case WhatsApp is too big to handle. It's a big file. The module is a booklet kind of thing. So you want it on your email, just send me your email ID. I'll mail it to you. Okay? So all the best, people, and stay safe with the incoming cyclone and all that. Just last week there was a cyclone in the eastern part of the country, where my parents stay in Kolkata, so that was huge stress for me. But by grace of God, everything was fine in my hometown. And now the cyclone is going to hit us tomorrow, so all of you please be safe. And that's it. Okay, see you next week. And for any mentoring, just join me this week.